Hey, yeah, welcome to this tutorial on, lesson on scalability. So we're going to talk about how websites like Google and YouTube and stuff are able to serve like many people at once at the same time without much lag. And we're going to discuss, some of the techniques of implementing it and maybe get into some code. So that's about me. Why should you listen to me? Well, I mean, you don't have to, but I've been programming for 8 years. I'm a software engineer for 5 years. Oops, that thing, that whatever. Infrastructure architect, bridge pay. So we have a transaction process type about 5 ms. Infrastructure architect is sent, and we get about 1K page requests per second on the cheapest digital ocean droplets. And application engineer at somewhere where I work on image processing stuff, but I do not really do that very well. But it's fine because learning is great. So what is scalability? Well, scalability is really the ability of a piece of software or service to just serve a large number of users without a decrease in user experience. So for example, it's really important with like web services. So like say stuff like, Google, Facebook, Amazon, Netflix, Spotify, etc. All these things, right? They have lots and lots of users, millions of users, maybe every second, but they need to, you can't have your users get a significantly worse quality of life than other users. So, and we are going to switch over to my iPad screen. Okay, so welcome over to my iPad here, where we are currently looking at the sketch of a simple web application that has been designed with scalability in mind. So very sorry for my bad handwriting and general messiness, but I'm not a writing specialist. I'm a software engineer. But anyway, that's enough on that. Let's move on. So as you can see here, we're going to point out some of the key features we notice in this application. So here we see we have a load balancer. So what a load balancer does is a load balancer basically even does, the name what it says, it evenly tries to distribute the load on hitting an application across multiple different servers. So for example, where you have Google search, right? You see google.com, but actually, the google.com server isn't actually one server, just not one giant server. It's actually many, many, many small servers that are able to service your search requests at the same time. So when you hit google.com, what you hit first is their load balancer. Then afterwards, their load balancer determines which of these apps, their Google search apps, they want to distribute to. So as you can see, app is basically simply a app server. So we'll discuss more on what a server is later when we move on to the Docker part. So as you can see, all these apps are able to scale horizontally. So scaling horizontally just means deploying more instances of these apps as they are needed. So usually your load balancer will connect with your container orchestration engine, which we will also discuss later when we get to Docker. Secondly, afterwards, your app wants to hit your cache layer. So a cache is simply just some form of temporary storage for data that may be accessed very quickly. So some examples of caching services and cache engines include Redis and Memcached. We will discuss about that in future episodes, but not for now. So finally, after we hit the cache layer needs something to read the data for. So we will need to read our data by communicating to something like a database manager. Apologies for the spelling here, but it's manager, yes. So yeah, do take note. It's not actually, okay, whatever. It doesn't matter. So our database manager basically manages our databases and ensures that the information stored across, oh crap, that's an eraser. The information stored across them is consistent. So we don't really want, if we make a app request here and we are storing the data to this database here, if we are storing it directly, let's say, what if this process here takes too long and the user reloads the page and they hit a different app server and now their database gets stored here. So now we have data inconsistencies between these two databases, and that's not good. We want to prevent that. So we're going to use a database manager instead to ensure that the data is carefully distributed across the databases. But obviously, we don't really want to be hitting databases directly. We would much prefer to hit something like the cache, which actually lives inside a RAM of a server and is much faster than accessing a database most of the time. So we will have a caching layer, which the apps will hit first, which provides us with additional layer of redundancy and failsafe, and allows us to scale app horizontally much faster since, a lot of searches may be cacheable. Although it is true that Google does see a lot of unique searches every single second. But, they still have a cache because you can cache a lot of stuff. So yeah, we're going to move on to the actual Docker part soon. So now that we've done with that, let us move on to doing some actual stuff. First important thing, we're going to want to install Docker Desktop if you're on Windows or Mac, and install Docker Engine if you're on Linux. So I have instructions here on the screen, but they will be down in the description as well. And also they will be available freely on the Docker website if you just Google it. It is very simple. So, hello everyone, welcome to my Linux development machine. So, I'll assume everyone has Docker installed by now. So, if we open up a terminal and type in docker run hello world, we should be able to. And as you can see, we should be able to get this message. Now, if you do in fact get a message that says you don't have permissions to execute a Docker command or something like cannot connect to var run docker.sock, you might need to restart your computer. Alternatively, if you're on Linux, you want to do sudo usermod-ag. Then I believe you want to put your group, and then you put your username here. So now that Docker is running, we're going to have a look at how containers work like that, and how the best way to do that is by actually building something. After I relog here, we have PyCharm. That's professional. I'm using professional version. You don't need the professional version. You can just use the community version. If you're a student, please go to GitHub for Education, sign up to your student email. You can get PyCharm Professional for free for 1 year, along with every other JetBrains product for free. So here's what I'm going to do. We're going to quickly start a new project, and we are going to start it with pure Python, because I'm assuming the community version doesn't have access to the Flask option. But yes, so we're just going to start a project. Let's call it YouTube, because, you know, as a standard, we need to call it YouTube. So let us create a new virtual env environment. If you do not have a virtual env installed, you might want to consider doing that, but this is out of the scope of this video, and the owner of this YouTube channel will cover Python virtual environment management in depth, I hope. Right, so let's create our PyCharm project. All right, and let's ignore these stupid notifications. I don't care that GitHub Copilot is updated. So now as you can see, we have just started a empty Python project, and we're going to show this because Discord. So now that's a bit laggy. So what we're going to do is we're actually going to create a requirements.txt file, typo, and the requirements.txt file is all it does is simply it specifies what dependencies are needed for your Python app to run. So we're going to specify Flask. We definitely need Flask to run. And as you can see, JetBrains' PyCharm is giving me a hint, and I'm going to want to install Flask. And now we've installed Flask. Very nice. So now we're going to want to make a server.py file. So let's going to call it server, and we're going to create a Python file. So from what we're going to do is we're going to simply create a very simple website that runs inside a Docker container. So we're going to quickly code this up. So from Flask import Flask. Oh, right. Yeah, I don't think so. Is it not Flask? Huh, that's weird. I don't think I have it installed. Okay, there we go. So just need to from Flask import Flask. App equals to Flask name. So I'm not going to cover what I'm actually typing here, because this should, I believe the owner of the channel should be covering this eventually. Please. Thank you. So we have created a Flask app, and we are just going to we're going to register root there. We're going to app.root / and then we're just going to app.root/. So we have simply created a simple Flask app. Now if I click on run server, and it should immediately pull up this. So if I fire up 127.0.0.1, oh, that's an issue. After we type in localhost 6969. Oh, that is strange. Yeah, oh, right, there we go, that's why. And I forgot to put that, so we're just going to quickly restart this. And if we go to localhost 6969, we get hello world. Right, so so now we have a hello world app running, so we can simply stop that. As you can see, this is a app server. This will be what we consider app server. There'll be more complicated app servers. I will go into that hopefully in the future after the owner of this channel goes into a deeper tutorial on, you know, things like Flask and website servers. Alternatively, there are plenty of good tutorials outside. I'm not going to cover it today. So now we have our app, we are going to want to package it into a format that Docker will understand. So let's do, now what we're going to do is we're going to create a Docker file. So a Docker file is simply like it's like a make file or whatever. It's a file that tells Docker how do you want to package your app up into a container that can be deployed on the Docker platform. So what a container is A container is simply a single unit of software that has all its dependencies and whatnot all packaged into one neat unit. So this makes life much easier because you can deploy them on servers without installing 10,000 dependencies every single time you want to run them. The good thing about containers is that if you architecture them right, they scale horizontally very, very well with the use of container orchestration technologies like Docker, Swarm, and Kubernetes. So let me have some water here, so just give me a sec. Oh no, that's water on my Mac. All right. So for the purposes of this video, we are going to go to Docker's hub and we're going to find a suitable base image to start our container off of. So simply a base image is basically, so every Docker container gets packaged as a image. A image is a basically, it's like when you install Windows or something, some other operating system like that. An image basically is like all the files and stuff that's needed to run an operating system. So think of Docker as kind of like a mini operating system running on top of your computer, but except it's not actually operating system. It's just running, just the dependencies and whatnot. So since we wrote our thing in Python, we might want to find a Python container. So Python was over here. There we go. So we're going to grab the Python image. Well, I guess we can just grab Python. So we were running on Python 3.9, right? Yeah. So we're going to grab the Python 3.9 tag. So as you see, tags are simply, tags are, the tags will be explained in the Docker hub page for the image. But for this purpose, we will go into that in depth in the future because this video will be way longer than 10 minutes if we go to depth now. So let's find a tag as well. So we're going to grab 3.9 simple side. So we're going to do from Python 3.9 slim bullseye. So this from tag basically tells the Docker we want to base our image off of this base image. So in this case, we're basing off the Python base image. Now we want our app to actually be runnable within the container. So what we're going to do is we're going to do copy dot and into /app. So what the copy command does is what I'm telling it to do is it takes two arguments. The first argument is the current directory it's running in. So of the current directory, the file is pasted. So what we're telling Dockerfile to do is to copy all of these things here into the app folder. Now, once you copy all these things in there, we might want to run the pip install command. So actually we need to run pip install -r requirements.txt. So what this command does actually, pip install -r requirements.txt is actually the same command if we do here, pip install -r requirements.txt. What this command would do is it will try to grab Flask and all its dependencies here, but as you can see, we already have them installed, so nothing to do here. So when we run pip install -r requirements.txt, we have now done that. Now we want to tell the server to expose a port. So our Docker container needs to have a port exposed. So we can see, as you can see, we are running the app on port 6969. So what we're going to do is going to hit and type expose 6969. So this is actually just a guideline. Docker does not immediately need to expose the port 6969. You have to do it yourself, but that's fine. We will leave that there because it's simply good practice to do so. And finally, we are going to move over to our entry point. So we're going to do entry point python server.py. So what entry point does, I'm not sure if this is actually correct. One sec. All right, so the entry point command basically tells the Docker container what command we want to run when it starts. So we can try, so for example, we can simply run it right now. Docker run YouTube, we need to, so when we finish building our Docker file, we can see that IntelliJ has helpfully provided us with a run button. Oh wait, this is a professional version. All right, you will have it. I'm not sure if you have the free version. All right, so I see we don't have it the free version. So anyway, it's fine. We're just gonna open up terminal. We're gonna run Docker build -t YouTube. So what the -t flag specifies is basically, a nice way to name a container. So Docker build dot, so dot means, which is the current directory we're going to look for the Docker file in. So as you can see, we're looking for here, and we're going to tag it with YouTube, and I'm just going to specify some other stuff here because it's cool, but you don't really need it. Oh, interesting. So I believe, oh, yeah, so I forgot to change my directory. So let me quickly do that. All right, okay, so there we go. So work the app. So we actually need to change our directory into app before running pip install requirements because it's going to find the file. Just go Docker build. And we can ignore that because we're running in a Docker container. So if we do docker run, and as you can see, we have now started a Flask server, and we can try to actually launch it in our browser now. But if you find that we launch it, we may get an error. Connection server. The reason is because we did not expose our Docker container. So the format to expose a port when you run a Docker container. I'm not sure why it's not stopping. Oh, that is pretty annoying. Okay, 1 second. Okay, so let's just quickly delete that old container we created, and we're gonna try again. So what this does is basically it tells the Docker on your computer to forward the port 6969 from the container to your current machine. And we're gonna give it a name too because it's quite not nice. So we're gonna just name it THH because labs, because that's funny. And we're going to run the image. So YouTube latest. So this is simply the image we have just built just now, which this came from this Docker file. And as you can see now, if we open up this in the browser, oh, that's better. Okay, that is weird. I haven't. Okay, so I may have not followed the plot correctly. That's weird. Oh, I forgot to provide a app.py. So actually, let's name it server.py. Let's name it app.py instead. Does this choose the port? Let's have a look. Yeah, it does. Okay, so we're gonna set up Flask run dash port equals 6969. So you can see we have app.py actually. So that means this part is not even needed. So we're actually just gonna comment this out. So when we can see when we type in Flask run, it simply starts the app.py and it starts the development server. Right, so we're able to start a development Flask server with Flask run port 6969 on our local machine. So we're just going to set up a Docker file here. So we're going to set the entry point to python -m Flask run port 6969, and we expose 6969. So basically, this actually allows it to be accessible outside Docker. Yeah, so we're just going to use that. So using the latest tag here, using the colon latest is just a good naming convention. Like if you're pushing the latest file, we're just going to be using it for now because, you know, that's a whole rabbit hole in itself. And we've done it. So we're going to do the same command as we ran just now. We're going to run this and we're going to expose the port on 6969. And as you can see, we are running on the port here. So if we hit localhost 6969, and we should be able to access our Hello World application. So that is very fun, right? And now that's done. So actually we can now stop the Docker container. And we are done for this video for today. So thank you for watching. I will see you in the next video.